So as I was saying, we had a lot of fun yesterday with the pirate treasure map, and one of the things that I tried to ask every group was, does the order that you add them matter? I phrase it that way. What I said was, should you end up at the same location? And the first time I asked most people, most of the responses were like, no, I don't think so. There was a few people that said they thought maybe, but they weren't sure. And then as you went on more and more, and I asked the question again and again, more people kind of came over to the, yeah, you should end up at the same spot, right? And so now I ask you today, should you end up at the same location as your partner? The answer is a resounding yes. And a lot of people I showed this to, I said to them, if you went 3 up and 4 over, and your partner went 4 over and 3 up, well, you all kind of went, oh yeah, you're going to end up at the same spot, right? Does it matter that there's more? Shouldn't. Does it matter that they're at an angle? It shouldn't. Sorry? You did another 3?
No, except the form, but the 3 instead of the form.
Yeah, but those are different variables, different vectors. Fair enough. But you're saying if you go 3 over and 4 up, those are 2 different, but that's not, you're not adding the same vectors.
Yeah, but we didn't have the same order, so it would be like that.
But you have the same vectors. You have the same vectors just in a different order. You're telling me to add different vectors, right? 4 over, Vinny, whoopsie. 4 over is not the same as 4 up. They're the same length, they're not the same vector. They got to have the same direction. Okay? All right. So that's kind of what this is today, and then we're going to actually add vectors by Pythagoras. So I'm just going to do a little quick review about vectors. So vectors is a quantity which has both magnitude and direction, like the supervillain. Examples of vectors include displacement, velocity, acceleration, and force. To fully describe one of these vector quantities, it's necessary to tell both the magnitude and the direction. And I showed you this method here where you've got 0 on top, 45, right? And you go clockwise. I showed you that. And I told you that that's what navigators on airplanes and ships actually use, right? And I talked to you about the runways and all that good stuff. There's a link there for Wikipedia, but good stuff. And I told you about the 3 types of direction notation, like 30 degrees, that should have a degree symbol there. I realize your handout doesn't have this. 30 degrees south of west, west 30 south, and 240 are all the same thing, right? And you're going to have to be multilingual. I've had students say to me in the past, Mr. Bennett, when they see that on the exam, they go, we've never seen that before. I'm like, yes, you have. So just be aware, I expect all 3 conventions that you can handle. Okay, so let's talk about vector addition. This is the handout that you have, right? All right. So it says most of us, what is 6 plus 8? What does 6 plus 8 equal? Some people say 14. I tend to disagree with them. How come? You guys give me the what face? 6 plus 8 is indeed 14. Well, what if I said 6 plus 8 is also 10, or maybe 2, or maybe 5? You might think that I've lost my mind, much like I've lost my hair. But I would be right about this, right? When you become students of physics and approach the task of adding vector quantities, we soon become aware of the fact that the addition of 2 vector quantities with magnitudes of 6 and 8 will not necessarily result in an answer of 14. I'm going to make it a smidge bigger. Hi, Dawson. I don't know where they are. The rules for adding vector quantities are different from the rules for adding 2 quantities arithmetically. When I say arithmetically, I mean like grade 3 math, right? 6 plus 8, you guys said it was 14. Vector addition is different. Now, I hate to tell you this. Well, actually, I'm pleased to tell you this. You all did vector addition yesterday. I just didn't tell you that's what you were doing. And you all did wonderfully. Hardly anyone did it wrong. Okay? I mean, you made some mistakes, but it wasn't the vector addition you did wrong. Some people just went, like, got east and west mixed up. And I should say this, in 20-some years of teaching, no one gets north and south mixed up, but east and west, there's like always 15% of the class gets it wrong. And I can't explain. I don't know why. But generally, you did vector addition quite well yesterday. Let's investigate. Vectors are quantities that include a direction. You guys have all this, right? You can follow along. You might want to highlight as we go. Vectors are quantities that include a direction. As such, the addition of 2 or more vectors must take into account that the quantities being added have a directional characteristic. In other words, you don't have to also add the numbers, but you also have to, and I use air quotes, add the direction. Now, how do you add the directions, Blake? You did it yesterday. You did. Basically, you have to draw them with your protractor. That's all I'm saying. You have to account for the fact that there are directions here. And there are a number of methods for carrying out the addition of two or more vectors. And they range from the really simple to the really complex. In grade 12, I'll show you a little bit more mathematical way to do it. Now we're going to do it completely geometrically. Physics textbooks can make this far more confusing than it really needs to be. It's not that hard. It really isn't. The most common method is the head-to-tail method of vector addition. There it is there. I tend to call it the tip-to-tail method. Okay? So the head of one vector, or the tip of one vector, to the tail of the next one, which is exactly what you did yesterday, and I didn't tell you how to do it. You just did it. You intuitively knew that if you're doing that treasure map, you're going to just keep the vectors going from where they are, right? Just like that. That, what you did, is known as tip to tail. And oddly enough, once I tell you what the name of it is, then you start getting confused for some reason. I don't know why. Using such a method, the first vector is drawn to scale in the appropriate direction. The second vector is then drawn such that its tail is positioned at the head of the first vector. So in other words, make it look like that, like you did yesterday. Tip to tail. Do they have to be the same scale? Like if one is 1 centimeter equals 5 kilometers, the other one is 1 centimeter equals 10 kilometers, is it going to work? No. It's got to be the same scale for the whole question, right? All right. Now here's where I'm sort of going to build on what we did yesterday. The sum of two such vectors is then represented by a third vector, which stretches from the tail of the first to the head of the second. This third vector is known as the resultant. When you add two numbers together, what's the answer called? Don't say answer. The sum, right? When you add two vectors, the answer is called the resultant. Because you have to include that direction thing. The resultant is the vector sum of the two individual vectors. And of course, the actual magnitude of the direction of the resultant is dependent upon the direction which the two individual vectors have. So if I were to draw the resultant here, where would I draw it? I will draw it in red. From where you started to where you end. And we're going to label that with the letter R. R for resultant. And in fact, it should also have a little thing over top too. Okay? Now, the most common mistake I see is this. Are we good, Anna? Having a lot of fun over there. The most common mistake I see is this. People want to complete the circle. They want to go like this, do it in blue. They want to go like this, and like that, and they want to go like that. Because they say, well, I got to make them all tip to tail. No. The only thing that has to be tip to tail is the two that you are adding together. These two need to be tip to tail. And the resultant is, think of the resultant, right? If you had your 6 or 8 or whatever directions there were yesterday in the pirate thing, if I had you draw from where you started to where you ended up, that would be known as the result, right? It's like a shortcut to the end. Think of the result as a shortcut to the end. Okay? It's from where you start to where you end. Now, are these tip to tail here? Are they supposed to be? No. Only the black ones. The ones you're adding together have to be tip to tail. The resultant doesn't have to be there. It doesn't have to be tip to tail. Okay? Is that good? Now, how are we going to get that result? How are we going to find out how long it is? Golly, what possible way could we find out how long something is? We'll get there. Are you starting to see why 6 plus 8 might not be 14? Oh, there it is there. Very disappointing. I'm very disappointed in myself. All right. So how do you add vectors? Actually, that's the theory behind vector addition. Now I'm going to actually do it. When two vectors are in the same direction, easy to add them. Just place them head to tail, and like just add them together, right? Because 8, 6, total length, 14. Easy, straight line. Easy. And then for some reason I got it double there, yeah. Does the order that the vectors are added matter? Say it out loud. 6 plus 8, 4 was 8 plus 6, still 14. The order doesn't matter. What if they're not in the same line? How do you add them? Same rules. Place them tip to tail, measure the result. There's 8, there's 6. What's that going to be? Is it going to be 14? No, it's not. How are we going to find it? We could use a ruler, or if it's a right angle, right? If and only if and only if it's a right angle, the vectors are perpendicular, and then you can be done using Pythagorean theorem and basic trig, which is what we're going to do right now. Okay. Here's one to practice. Well, maybe you know what? Let's go back. Let's do this one here. Do I have it here? Do you guys have a space right here? Okay, let's do this one. Let's do this one here. Okay, so I'm going to label this with an R. What does the R stand for? Resultant. And you're going to write R squared is equal to what? Does it matter if I write 6 squared plus 8 squared? No, order doesn't matter. Now, how many steps do you need to write out here, do you think? Does everyone want to do this? 64 plus 36, R squared is equal to 100, R is equal to square root 100, R is equal to 10. That seems like a whole lot of steps to me. Can we like condense that down, do you think? I'm quite happy to see that. If you feel you need to write it all out, you go right ahead. But we're all big boys and girls. We should be able to do 8 squared and 6 squared in our head and know that it's 100 and know you have to take the square root of it and then show me the answer. In fact, by grade 12, you're probably going to be going straight to the last one. Okay? You show as many steps as you need, but you don't need to. Am I done? That's 10. Am I done? I heard a no and I heard a yeah. How many people say yeah, we're done? How many people say no, not done? How many people have hands? Apparently we have people with no hands in the room. You're just afraid to be wrong. We're not done. How come? Because the resultant is a vector which needs a direction. How are we going to find the direction of that? We're going to use Sakatoa, right? Which angle am I trying to find? I'll label them. A or B? Which angle am I trying to find? How many people say A? Come on. How many people say B? How many people have hands? Very disappointing. The answer is A. You are trying to find the angle of the start. You need to know what angle to drive at, right? Like if I tell you to fly your plane at a certain direction, and when you get there, turn around and look at me, and that number will be 30 degrees. Does that make any sense at all? No. If I tell you to fly in a certain direction, you want to know what direction to take off. From the start. From the start. It's surprising how many times I get kids doing that wrong. So how am I going to get vector A? Well, the 6 is opposite the A, and the 8 is actually, what is that called? Adjacent. Which one of the three has opposite and adjacent in it? Which of the sine, cos, or tan has opposite and adjacent in it? Tan. So you're going to write tan. And what do we use the symbol for angles? Theta? Did I hear theta? Okay, the Greek letter T, theta. Tan theta is equal to, now you might want to write, and I'll do it now, because I know some kids like it. Tan theta is opposite over adjacent. Tan theta, the opposite side is the 6 over the 8. And there's always kids that struggle with which one's opposite, which one's adjacent. If you have trouble, call me over and I'll go through that with you. Adjacent means what? Beside, right? Anna is adjacent to Jen. She's beside her. Okay? Alana is opposite if they turn around. Opposite, adjacent. Beside or opposite, right? So 6 over 8. Now what next step? How do you get this number now? How do you do it on your calculator? Remember? This is what I want you to write. I want you to write theta is equal to tan minus 1. 6 over 8. What does the minus 1 thing mean? Inverse function. It means the opposite. Don't take the tangent, take the inverse tangent. When do you take inverse tangent? When you're finding the angle. So on your calculator, grab it right now. Let's do this together. Some of you have fancy modern calculators. Some of you have what we call reverse Polish calculators. In other words, some of you are going to go second function tan 6 divided by 8 equals, and you should all do this now, so you know what kind of calculator you have. Thanks, man. Some of you are going to go second function tan 6 divided by 8 equals, and some of you are going to go 6 divided by 8 equals second function tan. That's called reverse Polish. Okay? It's just the way the calculator is programmed. Whichever way it works, you get the same answer, but you got to know which way it is. This one here is reverse, I think. So I'm going to go 6 divided by 8 equals, and then I'm going to go second function tan. And you get what number? Yeah, 36.9, I guess, right? 36.9 degrees. This is all stuff you've done before, just not in this context. Now what have I done? Almost. When you say 36.9, you still have to include the references, okay? So that's 36.9, this angle here. So that's actually going to be, which direction is this? East. So that's going to be east. And let's round that 36.9 up a bit. Let's round it to 37. That's okay. So that's going to be east 37. What? North. How do you know what the east and the north, what directions they are? Well, the 8 is east and then 6 is north, right? Like it's kind of self-obvious. How many marks would something like that be worth? 1 there, 1 there, and maybe, depending on whether I give you the picture or not, 1 more. Are you ready to practice? I've given you the skills. If you've been paying attention, you can do it. Are you ready to practice? 2 minutes. How about I do the first one right now, and that way if you're getting to the second practice one, just in case you got something a little bit wrong, we can fix that up. So we got a man walking 3 kilometers north and then 1.5 kilometers east. What is his resultant displacement? This is a vector question. So you're going to go 3 kilometers north, and you're going to go 1.5 east. Okay? Does it need to be to scale? No. I know that north and east are perpendicular. I know I can see the future. I know I'm going to use Pythagoras, so I don't need to worry about scale. If you want to, go right ahead, but it's more than you need to do. Okay? There's my resultant there. I like to draw it in a different color. You want to? Some people like to draw a dashed line for the result, just to sort of separate it. Okay? And now you're going to write something like r squared is equal to 3 squared plus 1.5 squared. And now maybe you need to do a little extra here. 3 squared is 9, 1.5 squared, so I've got like 9 plus 1.5 squared, 2.25, so I got the square root of 11.25. 25. Which is, we'll say 3.4. 3.4 what? These are in kilometers. 3.4 kilometers. And you also need the angle. And right? That angle down there. Always the angle where you start. If you want to draw a little X or a little crosshair or something other to indicate the start, that's fine too, right? It's where you start that matters. What angle is this? Is it always going to be tan? Well, tan is always opposite adjacent. When you're doing this kind of thing, are you always going to opposite adjacent? Because if it's a right triangle, right, you're trying to find the hypotenuse, so that means you know the other one's opposite adjacent. It is in fact going to be tan. And I'm okay with this, just sort of condensing it down. I'm okay with theta equals inverse tan. Opposite is 1.5. Adjacent is 3. Okay? You can just start with that. You don't need to write tan equals opposite over adjacent. Tan theta is equal to 1.5 over 3. Theta equals inverse tan. Okay, that's too much, right? This is fine. And then just the answer. So 1.5 divided by 3. Second function, tan. Where's tan? 26.6 or 27. I like to round up to the full decimal, to the full degree. So that's going to be 27 degrees. Is it totally done? No, I need those directions. So it was 3 north and then east. So north, 27 east. Did you get that? Yeah. Are you going to get exactly the same numbers as me? You should. I mean, if you take out the round, you should get the same numbers, right? Like, Pythagoras is the same for everyone. We're not using the rules. Okay? When you can, use Pythagoras. But again, this only works when the triangle is a right triangle. Okay. I'll give you another one for this one here. I'll give you another bit of time. Try it. Does the fact that the second one is kilometers per hour cause any problems? Doesn't mean you do anything different. It just means that your centimeters are representing a speed. That's all. So your answer unit is going to be in kilometers per hour. So it really doesn't, sort of from like a step-by-step standpoint, it has no effect whatsoever on the steps. Right? It's still the same way. So we've got 100 kilometers an hour east and then south. So we've got 100 and then we've got south 25. Right? It has no effect. The result is there. If you want to see the answer to the practice one, I'm doing it right here. I get 103. 103.1, did you get that?
Yeah.
Yeah? Good. And then this is for the second practice one. Theta is inverse tan opposite 25. Adjacent 100. If you're having trouble with your calculator, call me over. I'll show you how to do it. And the angle here is 14. So that's going to be east, 14 south. East, 14 south. Okay, so a few minutes left here. Do as many practice problems as you think you need to do. I expect you to be able to add by Pythagoras.